And welcome to the desk of Ladyada.
Today we have a lot of presents, and we are present here as a present to you, viewers of the desk of Ladyada. It's me, Ladyada, at my desk and my computer, and with me is Mr. Ladyada, who is in a dark place. And
yeah, but the light and warmth of Larry fulfills us all.
Yes, thank you, Larry.
Yeah. Okay.
Very kind soul.
Yeah.
And we're going to be talking about more infrared stuff tonight. Yay! Everyone loves infrared. It's our favorite part of the electromagnetic spectrum. So last night we did a pretty long stream about infrared transmission and receiving. We talked about how there's a transmitter LED and a receiver diode, and you emit pulses of IR light, and that's how your remote control works, like this little remote control I got here, or even your TV remote, or your, I think Alexa has a remote, and then, what else is a remote? Like, yeah, Scott said his blinds have a remote control that's IR. Pretty common, low-cost way to make a remote control. No radio required. And so we did yesterday is we got the receiver working, and we tested it with our little remote, and we made a little demo. So let's go to the overheady. And I can just show the demo really fast. So this is the receiver Circuit Playground Express. This is the board we're working on. And the receiver is over here. And then this is my remote. And you can see when I press the button, it blinks infrared light. And then when I press the volume up button, it turns blue. And when I press the volume down button, this LED turns red. So it's a really good way to quickly check if my receiving code is working. And what's neat is you don't have to be exact. Like, you can kind of like point it away a little bit and it still works. Like, this would be pointing right at it, but the light does bounce off stuff a little bit. So if I have my circuit playground here and I point it at the table, it bounces off. So that's the nice thing about the IR light, is that you can bounce it off rooms a little bit. Not great, but it does work, just like, radio bounces around, the light bounces around as well. So that's good. So we've got the receiver working, and that's this little chip over here that we talked about yesterday. There's a diode, a pin diode, a positive intrinsic and then negatively doped semiconductor.
So
it's so dope. It's so doped, it's intrinsic. And then we have an automatic gain control chip that reads the signal and does the filtering for you, and it's 20 cents and it's a good deal. And we talked about how you can also get all-in-one little receivers as well. So that code's been done, but now it's time to use the transmitter. So over here, this little component, the clear LED on the other side, I'm getting close because it's time for closeness. So this is the this is the receiver diode, and this is the transmitter diode. The transmitter diode is clear. And it's basically the same as the LED that's in the tip here of this transmitter, except it's surface mount only. And there's a really neat property of IR LEDs in that, unlike red, green, blue LEDs that everyone here is used to, your standard like blinky LED, even the LEDs in these NeoPixels or this little green LED here, IR LEDs can handle pulses of very high current. They're designed, the way the die is made is just, because it's not meant for creating illumination or color. It's meant to like transmit data. You can pulse current through an IR LED up to like an amp. Way more than you can do with a red or green LED. If you took this green LED and you put an amp through it even for a microsecond, it would pop. But IR LEDs are happy to take extremely high currents.
Let me know when you want to do some questions.
Yeah, now would be a great time to do some questions.
Okay.
I would love to answer questions.
Okay, completely inspired. Love your explanation of the TSOP IR receiver chip and how they offer filtration. Is there a similar filter chip for sound or vibrations?
Wow, that's a good question. It's not as simple because those automatic gain chips for IR really are tuned for the 38 kilohertz frequency. If you're filtering for only one frequency, life is really easy. Life's good when you have only one frequency you're looking at. When you're looking for stuff like sound or vibration, you often want to tune the frequency. That's when you would use like a fast Fourier transform program. It's a little tougher because you would have to write that, you have to take software that exists and then look for that one frequency. There's tricks you can do for filtering for single frequency, that you can convolute it with the frequency you want and see if you get a spike there. But it's not, there's not like a chip that does it really.
Okay, the code that you're writing for this is it Arduino? Is it Circuit Python?
That's a good question. This code right now I'm writing is for Arduino. I'm actually porting the IR remote library and using the IR lib2 library from Chris Young. They're two infrared remote libraries. I've written code for infrared remotes, and you can do it, but these libraries are really full-featured. They're very well written, and so I would like to use like their work and promote it and support it rather than trying to like write my own library from scratch. What's nice about their library is it supports multiple different protocols like Sony and Panasonic and NEC, so that people can use remotes around the house. This remote is an NEC remote. It's a standard basic protocol, but a lot of people, for example, if you have an Apple device, you'll have an Apple remote. It doesn't use the NEC protocol. It's slightly different timing, and so using a well-featured library, you'd be able to receive or send data to and from an Apple device.
Okay, follow-up. Thinking piezo transducer receiving marks and spaces convert to IR blinks and then filter to chip.
I mean, if you are absolutely sure that
That's motivation.
the piezo is going to be...
It's like Morse code or something.
Yeah, if it's going to be vibrating at 38 kilohertz. Chances are it's not, though. Chances are you're looking for a specific frequency. Although, piezos can vibrate at 38 kilohertz. What you want to do is probably do your own signal filtering. This is something like a Teensy, which has audio filtration capabilities due to the built-in DSP functions. Like the Teensy 3.2 even has like a drag and drop system. You can create filters. That would be where I would go. I wouldn't use these chips because they're really tuned specifically for adjusting the gain on these diodes, not for connecting to another device. Like they don't understand things that aren't pin diodes.
Okay.
What it is.
Keep going.
All right, so let's actually go to, I want to go to DigiKey and we'll look up an IR LED because these are kind of neat. Although actually, we have them in the Adafruit shop. I'll show that really fast too. So.
Happy Robotics Week.
That's right. Okay, let me get this over here so you can see it. Okay, so this is an example of a super bright IR LED. Again, there's that 940 nanometers. It's the frequency of light that we're using, the wavelength. And they're great for whenever you want to, again, make your own remote. In this case, you would connect it up to your Arduino or even your Raspberry Pi or whatever. They work best with an Arduino, something with a timer output. So let's look at the technical details. So this is from Everlight. I love Everlight because it's like they make LEDs and they're like, they just took a photo on their desk and just pasted it into the data sheet. So cool. This is the IR LED, and it's made out of gallium, aluminum, arsenic, I guess. Standard 5mm LED, but then when you look at the absolute maximum ratings, you can see here it's happy with up to 100 milliamps continuous forward current, which is a huge amount for an LED. Again, most red, green, blue LEDs, they don't like more than 25 milliamps. You can do 100, but they don't like that for a long time. And then the peak forward current is an astonishing 1 amp, but it wants to have it with low pulse width and low duty. But still, 1 amp, that's what you can do with these LEDs. You can really abuse them, which is awesome. And they also have a pretty low forward voltage. When you peak drive them at 1 amp, they can go up to 2.6 volts or 4 volts. But, for what we're doing, about 250 milliamps, think about 2.5 volts. What's up? Is there more questions?
Okay. Not all devices use 38 kilohertz IR, so what about those?
When you're using devices that aren't 38 kilohertz IR, you would get a filter chip that is tuned for that frequency. I'm using 38 kilohertz. 99% of IR is 38 kilohertz. But there's 34 and there's like 56 and stuff too. Okay, so this is the through-hole LED, but I'm using a surface mount LED, but it's very similar. Basic idea. You can peak drive them very fast, which is cool. And so that's what I've got going on in here. Actually, oops, I closed my schematic. One moment. Let me see where. While I open it up.
Tonight we'll be featuring the monsoon.
There will be a monsoon. Okay, so here we go. So this is, oh, can you hear the computer?
Yeah.
So this is that receiver. Again, we got that. That was covered yesterday. So now we're going to be doing this transmitter. And the transmitter is connected through a NPN transistor. You could theoretically drive the LED from a pin, but the pins on an Arduino or any microcontroller really don't like doing more than maybe 5, 10 milliamps. That'll work, but you won't get a really good distance for your IR. If you want to really make a TV be gone, you need to be able to pump at least 100, 200, 300 milliamps through the LED. So adding an NPN transistor will do the job. And then I just put a little resistor here to just protect the microcontroller pin. Just, I know it's current limited, but it's kind of nice to have another resistor just to be like, hey, there's no way you're going to seriously overdrive the pin. And then for the code, I'm using IR remote. Again, this is Ken Schrift's library. And it's pretty easy. You just set it up to send on pin 29. That's the pin I'm using. And then what I've done is I've set it up so there's the 2 buttons on the circuit playground. And when I press the left button, it'll send out this code, OXFB40BF. That's the same as the little pin on my little volume minus on my remote. And when I press the right button, it'll do volume plus. It's the other button on my remote. So basically, I'm cloning this remote onto the circuit playground. So I've loaded it up already because I wanted to save some time. So let's go to the overhead. Okay, so this is the circuit playground that I've got my transmitter code on. And so you can look here, that's that LED. And you can see, I can't see it, but thanks to the magic of no IR filter on this overhead camera, you can see really nice bright light coming out of that IR transmitter. And then when you have the other circuit playground, which is our receiver, so you have the receiver over here, and then the transmitter, when I press the button on this to transmit, I can change the color.
They're talking.
They're talking to each other. So bi-directional communication is possible. This one can transmit to this one, this one can transmit back if desired.
On a low-cost, solder-free board made for kids.
Yeah, and then
what will they do?
I can hold it up here.
Mm-hmm.
And still, it's still working. I just have to aim it at it. So finally, people are asking, well, how much current is going through this IR LED? Well, it's really hard, especially with the LEDs because they're non-linear. They're like logarithmic in the way, or exponential the way the current versus voltage goes, and also the transistor. The collector emitter voltage varies. You could try to do the math, but these components are not super precise. There's going to be variation. The best way to actually know how much current is going through the LED is to measure it. Now I can use a multimeter or I could use an oscilloscope, but it would be annoying because I have to desolder parts. So what I'm going to do is use my monsoon power meter.
Yeah, we're going to do that.
So let's go to monsoon power.
Yeah, can you move your? Okay, good, you did it.
Circuit playground?
Yeah.
Okay.
No, there was a thing in the way, but now it's not.
So now I've got this monsoon power meter in my disembodied hand. So this is a device that does can do a USB pass-through and tell me how much current is going through the USB and do all the measuring and graphing for me, while also data is going through it, which is handy. It also, you can connect up with these handy little alligator clip type things. But I'm going to be using the USB connection and the software. And if you're interested in buying one of these, you can buy them from Monsoon. Thanks to K-Town for pointing me at Monsoon. This is a cool thing. So then let's go to the computer and we'll wrap this up.
Yeah, sure. So
this is the Monsoon power meter software that you know and love if you've watched The Desk of Ladyada. And I have it hooked up now, so it's USB output and run. And it's giving 5 volts output. And the current draw right now is, what's really neat is I can change like the scale. I love this. The current draw is about 25-ish milliamps. You can see there's a little bit of spike here. I'm not sure exactly what that's from. Oh, it's from the PWM of the NeoPixel maybe. So that's that, but I want to measure what it looks like when I press the button. So this is, this is the transmitter again, and when I press the button, you'll see like, wow, it spikes up really high because all of that current is being dumped into the IR LED. So lovely. So the amount of current, I'll just hold this down so you can see this. So you can see that it's kind of spiky, and that's because we're doing that on and off for sending the LED data. LED IR data isn't like pure on and pure off. It's PWM, partially to make filtering easy on the opposite side, and partially so you don't put as much strain on the LED. And then you can see it peaks at about 200 milliamps. So about 175 milliamp of current going into this surface mount LED, which is actually pretty good. I'm pretty happy with that. Using only a single low cost, like 2-cent transistor for an amplification, that's kind of what I expected. Those little surface mount MMBTs are not going to be able to really supply an amp. I mean, or sync an amp. Like you can do it, but you have to have a lot of current going into the base, and this microcontroller doesn't really do that. But 200 milliamps, 175 to 200 milliamps is a lot of current. I don't really want to draw that much more because if you're USB powering, I want to keep the total amount of current under 500 milliamps. Or if you're powering it from a bunch of AAA batteries too, I don't want to actually have a full amp going out. So that's pretty cool. And I tested this with my TV, and I could actually, bounce it off the wall. So when you have a really good receiver, like from a appliance, you can get really good range with this. Yeah. Any questions?
Yeah. If someone's making their own NPN, isn't it giving enough transmit power? Would a Darlington pair help?
A Darlington pair would help, but you have, I think your VCE starts to dominate, and so I'm trying to think. You get a double VCE, right, with a Darlington? I know you definitely get a double VBE. It's one of those things where, we stock this component, and again, I could get more gain, but I don't really want more gain. I'm actually kind of in a sweet spot. So I might try different really low-cost transistors, but I definitely want something that's only a cent or two.
Okay. Some more questions from the chat. How many volts can the circuit playground take on? And then what is the simulation software that you're using for the waveforms?
For the voltage that you can power the Circuit Playground Express, you give micro USB power, which is 5 volts. And then you've got a JST connector, which can take from 3.3 volts, which is very minimum, up to 6 volts. Maybe a little bit higher, 6.5, because there's a diode protection. And there's also fuse protection. So I'd say like 6.5 volts is the maximum, but I recommend using like a LiPo battery if you're an expert, or 3 or 4 double or triple A's if you're just beginner and you don't want to deal with rechargeable batteries.
Okay. And what's the software that you're using on the screen right now?
Oh, this isn't simulation. That's actually live data. So when I'm pressing the button, that's the live data coming from the Monsoon power meter. I don't know if you remember the Monsoon power meter.
Yeah, I posted a link in the comments, actually the description of our previous video.
Yeah.
And also the other thing that people want is a link to it. Next up, how much data can IR signals transmit? Can we transmit small data packets?
You can transmit as much as you want, but it's IR on its own is very low level. There is no error correction or retransmission. So, we were talking about IRDA. What is it? 38 kilobaud. We're talking about. Yeah, if you look up IRDA, it's the protocol it's an established protocol on top of infrared receive and transmit, and I believe it's 9600 baud or 38 kilobaud. You can transmit data, but you have to have your two Palm Pilots right next to each other for the best support.
Okay. Next up, almost no questions.
Yeah.
Have you tried IR MIDI? Any issues with the idea?
IR MIDI, yeah, you could do that. What you would do is have, one device that is transmitting to your circuit playground, and the circuit playground acts like a USB MIDI device. So you could do it, but the thing about IR, just to remind you, is it's not, in and of itself, it's not very reliable. It's really meant for low cost, simple, I'm just sending data to this to and a lot of it relies on human control feedback loop. So, you press the button on the remote and you try to hit your TV, and if it doesn't turn on, you press the button again, right? So the way that I would expect people to use it with Circuit Playground is, you either use it as a remote control or you communicate back and forth. Bunny did a really cool project with IR and these round boards, which kind of inspired me to do this, where they send color data and then you can have color mixing change when you have, they reproduce with color.
Yeah, that'll be neat with kids. They can have a board with yellow LEDs, blue LEDs, and then once they communicate, they can become green together. Okay. I've got one thing before we go, but why don't you show your thing?
Yeah, I wanted to actually see if I could see the IR project that he did. What was it? It was called LED virus or something. Yeah, bacteriophage virus. So this is the project that he built, which is kind of neat. So it's these circles of LED light, and they had an IR receiver transmitter. It was based off of a Freescale processor, and you had a ring of light, and then they would basically be able to have sex. If you had a badge and someone else in your Burning Man camp had another badge, and they had two different light effects, they would merge the light effect. When you were next to each other, they would IR communicate and transmit the settings for the color and pattern generation, and they would basically do DNA combinatorics and come up with a new pattern that was unique. So I thought that was kind of a neat idea. Kind of inspired me a little bit. I was like, oh, that's a cool use of IR.
Okay. All right, we're out. I have two things. One, prions are weird, aren't they? Do you know about these?
The proteins?
Yeah.
Yeah.
It's not a virus.
No.
It's a thing that can it'll unfold and do all sorts of weird things, like mad cow. It's freaky, and it can lay dormant for a really long time.
Yeah.
They're freaky. They're super freaky. I was reading an article about a group of people that were cannibals, and they got this weird illness from eating dead people.
Yeah.
Yeah.
Which is like mad cow disease.
Yeah.
Okay,
so next up.
I'd like to use this moment to plug Bunny's book.
Oh, sure. I have one last thing
Yeah.
after that, but why don't you go ahead?
Read Bunny's blog and buy his book. You don't even have to buy it from us. Just buy it.
Yeah.
That's it. It's an awesome book.
Okay. Next up, if there's any Doctor Who fans, I need help with something. So this is the phone that's inside the box, where it says
TARDIS box.
The TARDIS, yeah. And I don't know the name of this. And you can, search for it, and you'll find that this is what it looks like. I want to either make one or find a replica that I can turn into a VoIP box. If anyone could post in the comments after the video posts on YouTube, that would help me out the most. I just need to know what the type it is. I want to do some research and find out, what was this called? What is it? Is this only a replica that's never existed? It looks like a really old phone from the UK, which would make sense. It has these brass bells at the top, and there's a ringer. and it's inside the little police box front of it. It says public phone inside it's a little one, and then when you open up the charges, of course, there's it's a lot bigger inside, but there's a little tiny phone and a little door. So if anyone knows, post up in the comments after the video's posted on YouTube, because right now if it's just in the chat, who knows where it goes? I don't know. YouTube doesn't store the chats. Twitch does, but I don't know what happens with YouTube. I think they're gonna add it as a feature one day. That is my request. If anyone knows, I'm sure there's a lot of Doctor Who fans out there. That's it.
Okay.
Okay, that was Ladyada tonight. We'll
That
be
was
on
fun.
Wednesday night at 7:30 p.m. Eastern Time for show until 8 p.m. Ask an Engineer. Your orders at adafruit.com. Support us, an open source hardware company that we fight hard. We love hard. We share hard. It hurts. But, picking up some kits and stuff helps.
Thank you, everybody.
So, yeah. All right, Ladyada, that's it.
Bye-bye.
Good night and good luck.
Good night.